Okay, this is a simulation or an applet here that is used to illustrate a very important type of interference pattern. This is referred to as two-source interference. Okay, so this right here is going to be the surface of water. Right over here and here are two coherent point sources of circular water waves. When I say the word coherent, what I mean is that the waves that are produced by these sources are identical to each other in every way. Same wavelength, same frequency, and the two sources are in phase. So I will demonstrate this in my ripple tank as well. This right here is just a simulation of this pattern. I wanted to show you this first before I actually show you what happens in an actual physical ripple tank. All right, at any rate, however, let me go ahead and set this into motion like so. And then propagating outwards from each individual source are individual circular water waves, which then encounter one another and they then therefore interfere with each other. And then like standing waves on a spring, what we end up with here is a series of nodes and antinodes. For example, right here is where there is a node. These are referred to as nodal lines. This is where you have a crest from one wave completely canceling out a trough from another, such that the water is completely flat. Here's another nodal line over here. And then in between the nodes, right here, for example, right in the middle of this shape, right here, this is where you have an antinode. This is where you have a crest and a crest overlapping each other to produce a really large crest. So this is a region of total constructive interference. And then right here is where you have a trough and a trough overlapping each other. So you end up with a really deep trough, and it's still, once again, a region of total constructive interference. So then therefore right here, this is what is referred to as an antinode. And then in between the antinodes and the nodes, right over here, this is where you like have, for example, a partial crest and a partial trough, et cetera, overlapping each other. We're not really concerned about that. But once again, you have here a region of total destructive interference. That's a node. Right here is a region of total constructive interference. That's an antinode. And then right over here, once again, is another node. I can adjust what the pattern looks like by playing around with the parameters here of the waves that are produced. Let me go ahead and clear these guys, for example. And then right here, I'm going to go ahead and raise the frequency of the waves. When I do, the pattern kind of tightens up, like so. Notice that you end up with a lot more antinodes and nodes, but then if you kind of like start up here and then go from one side of the simulation to the other, you see this alternating pattern of node, antinode, node, antinode, node, antinode, and so on. Okay, let me go ahead and lower the frequency once again a little bit. Let me clear these waves. And then I can move the sources around, for example, and when I do, you can once again see different sides of the interference pattern. Let me go ahead and set this in motion like so. And then when you see an interference pattern like this, it looks like it's horribly complex, but it's actually not. It's actually very easy to describe mathematically what conditions are necessary to have nodes and or antinodes at some portion here in the simulation, at some portion in the ripple.